Hello everyone, Suryansh here again. So in this video we finally get into 1.1, which is actually making the base. Now I did talk at length about how this video needs to be and what exactly I'll be doing in this video. So I will not do all of that again. We will just get right into it. We'll start talking about the base here onwards. Right. So I did actually make a sketch because I feel some of the things that I said last time weren't as clear. I did mention base, femur, and tibia, but I was later told that that might be confusing. So anyways, here's the structure. Now this is very different from a spider. Obviously it does not have, as I said, it's not an octopod, it's a quadruped. And it also has what's just called 2 joints per leg instead of the 3 to a torso. But anyways, just to introduce our nomenclature better again, this is going to be the base, that's the femur, that's the tibia, that's basically the convention that we're following. Now, truth be told, I have actually already worked on this project, at least to some extent, in middle school. And I did also then work by... so in middle school, I worked with Divyansh, who's a good friend of mine. And we made only some progress, not a great lot. And I started working on this again in my first year. And I did actually print the chassis. So we'll be making this again entirely from scratch because it's not perfect, but I still wanted to give an idea what the base will look like. This is the base, this is 3D printed PLA. So I'll explain what this base is and why it is the way it is. So if you notice these ridges, they are placed to make room for our microcontroller. Now my microcontroller is in this box, and as you might have noticed, I'm not using a genuine Uno, I'm using, one second. This is unfortunate. Ugh. Why is it taking so long? Anyways, yes, I have it out. Right, so this is an Arduino. It's not a genuine one. It is in fact made by Key Studio, who's a manufacturer. Pretty good, it's very affordable, that's why I got it. So as you might notice, this sits very perfectly in the ridges. Yeah, it in fact almost, you don't even have to screw it in, it just sort of stays there. Unless of course you flip it, then it will fall off. But yeah, my original plan was to stick it, but that was a blunder because if you notice, this actually does have some holes on it where you can get nuts and bolts and actually drill those holes and sort of make it more, I would say, robust as a setup. So that is something. And this is why we have these ridges. As for these ones, that's where we intend, or at least I intend, to place these. This is an SG90 micro servo. I have stripped off the sticker because it was getting in the way of actually putting this in. We'll be able to, when we start making the base in this video, we'll be able to find the measurements for this and this in the data sheets for Arduino Uno by Atmel and for SG90 by the manufacturers. So that shouldn't exactly be an issue. Right. So now let's start talking about how to actually make the base. Yeah. Right. So now let's finally start designing the base. So on my screen, I have 2 data sheets. You can find these on the internet with a simple Google search. You can search for the SG90 data sheet, which is the servo motor we were using. This looks like this. I have actually 4 of these, quite a few. And we will need many of these throughout the project, 12 or something, I suppose, 3 for each leg. And it's also very easy to damage them if you don't treat them very well, so we'll actually need more. So that's the servo, and this is the microcontroller again. It is obviously, the data sheet is very extensive. You can get all kinds of information there. But the only thing we really care about for our engineering drawing is this diagram, because we can get the exact mill holes and the exact dimensions for the entire board. Right, so the rough idea for the board is that, again, this is very simplified. Over time we will improve this design. This is an iterative thing. We don't care about getting it all perfect right now. Is that we want a very flat thing, and this is a bit 3D. So it's a bit thick. It's a bit like this. So you see how this is 4 millimeters thick. So this is a rectangle basically, and then within this we want to place the board. And if you look at the holes on the board, then that should be, there's one here, there's one here, there's one here, and then one there, right? So this is where it's screwed in, as you can see. So there's, yeah, maybe I should remove my fingers. There's one here, one here, one there, one there, right? And then we would like some of these, and these are tilted at a 45-degree angle, and they're kind of important because this is where you would actually place the arms, and the arms are out at this angle. Yes, and this goes here. Now this is a rectangle, and these are rectangles as well, so this is not exactly symmetrical. This is not a square, so this is symmetrical here and symmetrical here, except from the drill holes, of course. Otherwise the drawing is very symmetrical. The symmetrical and flat drawings are easy to make, and I will explain how I actually 3D print this later on. Right, so this is what we like. Now we'll start. I'll give a sense of what this is. So if you look at the diagram, the Arduino board is about 66 millimeters plus slightly more. Yeah, it's 66 millimeters here, if you can see this, and then a little bit more here. So we would ideally want this section to be around 68 millimeters. Let's just eyeball it. We don't really care about being precise, as I said. And we would like some padding space, and the padding space that I think is good enough is maybe 15 millimeters for now. Yep, and the same thing goes for the vertical section. We get a 15 millimeter padding space, and the actual section's height is in the diagram. It's given slightly more than 50 points, so this is 50.80, but then there's this section as well. It's slightly longer, so it's around 52 millimeters, I suppose. That's how much space we expect to center it on. So those are the rough, so these are, I'll say, rough, so that I remember they're not absolute. So that's the rectangle that we need to make, the first thing that we need to do, and we will start there onwards.